In this video, we are going to discuss the test of significance of difference between sample proportion and the population proportion. So let X be the number of successes in an independent trials with probability of each success as P, which is constant. Then the proportion of success in the sample will be X by N. Then this X will follow a binomial distribution with mean NP and variance NPQ. Because we know that number of successes in N trials is obtained by using binomial distribution. So X will follow binomial distribution with mean NP and variance NPQ. And if N is large, then we know that X follows a normal distribution, because normal distribution is the limiting case of binomial distribution when N takes large values or N tends to infinity. So X will follow a normal distribution, mean NP and standard deviation under root NPQ. Therefore, this P follows a normal distribution with NP by N and standard deviation as NPQ upon N square, because we have to divide by N. X is divided by N. So mean will become NP by N and standard deviation will become under root NPQ upon N square. Therefore, the test statistic is P minus expectation of P upon standard error of P. So this is standard deviation of the proportion P, which is also a standard error. So standard error is under root PQ by N. If P is unknown, then we can find 95% confidence interval for P using the sample proportion P using this formula. So this formula is for 95% confidence interval in case P is unknown. We can estimate P or give a range for P. So consider this example. Experience has shown that 20% of a manufactured product is of top quality. In 1 day's production of 400 articles, only 50 are of top quality. That means only 50 out of 400 are found to be of top quality. Test whether the production of the day chosen was not a representative sample or the hypothesis of 20% was wrong. Also find the 99% confidence limits for the percentage of top quality. So here if you note down the population proportion is given as 1 by 5. Sample size is 400. Proportion of success, that means product of top quality out of 400 is 1 by 8. So this proportion is 1 by 8. Here we set H0 as P equal to 1 by 5. That means the proportion of top quality product is 20%. That means 20% of the manufactured product are of top quality. And here H1 we set as P is not equal to 1 by 5. That means the hypothesis of 20% was wrong. Here level of significance is 1%. Therefore Z alpha corresponding to this level of significance is 2.58. That means 1% area on either sides. That means this is 0.5% area and this is 0.5% area. So critical region consists of 0.5% area, 0.5% area on either sides. So this is corresponding to minus 2.58. This is corresponding to 2.58. So this is the acceptance region. That means this computed value of Z must fall in this acceptance region. So if we compute the value, we find that Z is 3.75. So if we look at this minus 3.75 and compare with this value 2.58 and minus 2.58, then we see that this minus 3.75 falls somewhere here. Therefore, H0 is rejected. That means the difference between sample proportion and the population proportion is significant, is not by chance. The sample was correct, but the hypothesis of 20% was wrong. Now we find the 99% confidence limits for P. That means if the claim of 20% was wrong, then what must be the true claim? So using this formula, P minus 2.58 into under root PQ by N, P plus 2.58 into under root PQ by N, we find that the confidence interval is this. That means the claim must have been in this interval of 7.34 to 17.66. So the manufacturer's claim must be between 7.34% and 17.66%, but it was 20%, which is out of this interval. Now take another example. A salesman in a departmental store claims that at most 60% of the shoppers entering in the store leave without making a purchase. A random sample of 50 shoppers showed that 36 of them left without making a purchase. Are these sample results consistent with the claim of the salesman? If not, find the 95% confidence limits for P. That means if this claim of 60% is not true, then find what must be the true claim. So again, we suppose that capital P and small p be the proportions of shoppers leaving the store without making a purchase in population and the sample respectively. Then n sample size is 50. Capital P means proportion of shoppers leaving without making a purchase is less than or equal to 60, less than or equal to 0.60 as claimed. Sample proportion 36 out of 50 means 72. That means 0.72. Here we set H0 as P equal to P, which is less than 0.60. That means the salesman's claim is true. That means at most 60% of the shoppers entering in the store leave without making a purchase. But H1 is P greater than 0.60. That means the salesman's claim is not true. More than 60% of the shoppers leaving the store without making a purchase. So salesman's claim will be wrong in case we find P greater than 0.60. That means the difference between this 60% and this 72% significant. Then only the salesman's claim will be wrong. So here level of significance is 5%. We note value corresponding to 5% level of significance on one tail test. So on right tail test, this value is 1.645. So this is the critical region and this is the acceptance region. So let's see where this value of Z falls. So if we compute this Z, we find that Z equal to 1.7321 and this value of Z is falling in the critical region. This is 1.645 and this value falls somewhere here. So H0 is rejected and H1 is accepted. That means the claim of 60% was not true. Now what must be the true claim? So we can find 95% confidence limits for P using this. So for the claim to be true or H0 to be accepted, this Z must be less than this 1.645. This is Z alpha. So this Z must be less than Z alpha so that H0 is true. So using this equation, we find that P minus P less than or equal to 1.645 under root PQ by N. So here P must be greater than P minus 1.645 into root PQ by N. So solving this, we find that P must be at least 0.6060, but it was 0.60 only. So the salesman's claim must be at least 60.603% of the shoppers entering in the store leaving without making a purchase. But it was 60% only. That's why our claim H0 was rejected. So this is the confidence interval. The claim must be greater than or equal to 0.6060. Take another example. The fatality rate of a virus is believed to be 18.36%. In a certain year, 450 patients suffering from the virus were treated with a vaccine and only 68 patients died. Can the vaccine be considered as efficient? Take level of significance as 2%. So vaccine will be effective when this fatality rate is decreased after treating with the vaccine. So again, suppose P, capital P and small p with the proportions of patients died before and after treatment with the vaccine respectively. Then N is given as 450, sample size, P is 0.1836, population proportion, and small p 68 out of 450 means 0.1511. So here we suppose H0 as 0.1836, that means the vaccine is not efficient. That means the results obtained after giving the vaccine and before giving the vaccine are the same, or the fatality rate is same before and after treating with the vaccine. H1 P less than 0.1836, that means the fatality rate has been reduced after giving treatment with the vaccine. So here level of significance alpha is 2%. So we note down this value corresponding to 2% level of significance. So on left hand side we have minus 2.055. So corresponding to this level of significance, this is the critical value and this is the critical region. and we find that this value falls in the acceptance region somewhere here. So computed value of Z falls in the acceptance region, therefore H0 is accepted and H1 is rejected. That means vaccine is not efficient. That means the vaccine has not reduced the fatality rate. So this was the test of significance between sample proportion and the population proportion. I hope you understood what I have told you. Thank you very much.